We are going to start section 4.4, which is on conjunctions. All right, so as a review, if you have set A 0, 2, 4, and 6, you have set B set B is 1, 2, 3, 4, and 5. And then set C is -4, -3, -2, 0, 1, and 2. So we have 3 different sets. If I asked you, what is the union, or sorry, the intersection between set A and set B? What does intersection mean with sets? Y'all remember this from chapter 1?
No.
I know you weren't here. Remember we had intersections and we had unions. So an intersection is just the numbers that are in 2 sets or 3 sets, the sets being compared. And a union is a combination of the numbers that are in either one or the other. So they don't have to exist in both. So for the sets A and B, what numbers are in both sets?
2.
Right, we have a 2
And 4.
and we have a 4. Anything else? Nope, there's a 0 and a 6, which don't exist in B. So the set A intersection B is 2 and 4. Yeah. It's just symbols. Remembering what the symbols mean is the biggest part of it. All right, what if I said A intersect C?
That would be 0 and 2.
All right. So we have a 0 and a 2, is that it? Yep. All right. Abigail, let me give you one. Or 3. What if I said B intersection C? I know, that's why we're practicing. Because conjunctions are similar. So what's in B and C? We got a 1 and 2. I think that's it. Because there's no negatives in B, so you can ignore all the negatives in C. All right. That is correct. It's 1 and 2. All right, Gabe, what about? Excuse me. If I gave you A union of B intersected with C. First, I know, right? Got complicated quick, but it's still not that complicated. So look at what's in the parentheses first. What set is B? What numbers, what elements are in both set B and set C? It's our intersection. So let's define this guy. Oh, we actually did, right? We got it here. So B intersection C is 1 and 2.
Oh, okay. I didn't see.
So now we're looking at union, and I wrote it as a U instead of the way I was supposed to. Let's do it this way. There we go. So set A union set B means every element that exists in both A and B. So what would that equal?
B and C, 1, 2.
B and C is 1, 2.
That would equal like 0, 2, 4, 6.
Right. So between those two sets, A, which is 0, 2, 4, 6, and B intersects C, which is 1, 2, what would our new set look like? It's everything in both.
Oh, so it'd be like 1, it'd be 0, 1, 2, 4, 6.
There you go.
What?
What?
What? I don't remember.
What, why?
What?
Are you confused?
There.
Okay. This is what we're looking at now. You see how that's the opposite? It's a U instead of a.
That's an intersective and that's a union.
So a
Get that.
union means every element that exists in both A or in, what's the best way to say it? I'm bad with these phrases, but it includes every element in A and every element in B.
What about C?
Well, because this is not C, this is only B and C. See, A union set B intersects C. And we defined B intersects C as the set 1 and 2, that it contains 1 and 2. So really the only new number we're adding is the 1, because A already has the 2. I'll let your brain chew on it a little bit. Okay, it's okay. You weren't here for this, and I don't know what you had at GHS, so.
No, this was not. I don't.
All right, Eden, this one's yours.
If I did, I just cheated on all the tests.
Shh, I got you on video. You better watch it. So A intersect B intersected with B intersect C. So let's define our intersects and then we'll compare them. But either way, these are going to be pretty small because it includes only the elements that exist in both. So did we already defined them. Okay, so what's A intersect B? It's only the ones that exist in A and B, and we did it right here. No, intersection, intersect is only what exists in both sets that you're comparing. Union combines everything. But these are those upside down U's. They're like the mountains. So, what you call them? But those mean only the elements that exist in both sets.
Inverse.
2 and 4, right. Why did I do that? I didn't do that. And then that intersected with B and C, which we defined at number 3 is 1 and 2. Yep. All right, so what element intersects both of these sets? Yep, that's it. And that's our answer. Because that's the only one that exists in both.
No, I get that one. I just don't understand 4. I don't get the union stuff.
So,
Maybe
okay.
intersect.
Okay, so in number 4, we defined B intersects C as 1 and 2.
Right.
The guy I put below it there. Now what's in A? 0, 2, 4, 6.
Yes.
A union is like marriage.
So
Everything,
you add them together.
yes. You just don't duplicate. You see how 2 is in
You don't
both?
duplicate them, you just put the new ones into A.
Yes,
Okay.
yes, pretty much, because A is the big one
Yeah.
in this
So
case.
you put the new ones into the one on the left. Where
And-
it already is.
Yeah, like union, like marriage, everything that belongs to the woman and everything that belongs to man all becomes. But then they like give away their extra DVD set of the Lord of the Rings trilogy because they don't need 2 copies.
So, 8 seasons of the year.
Exactly, all 8 seasons of the American Office. But if she has the British version and he has the American version, then they might keep both because they're technically not the same.
I don't know why you watched it.
Exactly, but some people. All right, so that's all of them. I'm not. It's okay. All right, so when in relation to union and intersection, when we worked with sets, we do something similar with what we call conjunctions. Now, a conjunction, okay, let's look at example 1. Now we know what conjunctions are in English, right?
Yeah.
You have 2 independent clauses, otherwise known as sentences. You combine them with a comma and a conjunction. So this is somewhat similar. So for example 1, this just means we have 2 inequalities. And we graph the similarities between the 2, like what numbers, what values are a positive solution to both inequalities. So for example 1, they want us to show x is greater than -1, but it is less than or equal to a +4. And so when you graph these, particularly with conjunctions, you want to make sure that you graph the individual inequalities above your number line, and then on the number line is where you graph the solution. So when we look at example 1, you can see that we have, let me make my numbers here. Let's see here. I'll just -1, 0, 1, 2, 3, 4. Okay. So we have a x is greater than -1. That means it's an open circle at -1, not 1. And is any number greater than. And then we also have x is less than or equal to 4. So that's a closed circle. And then it's any number less than. So what is true for both of these inequalities? Not -1, right? So x is not -1, but it's greater than -1 and less than or equal to +4. So every value between -0.99, which is greater than -1, to a +4 is a true solution for both of these inequalities. Yes? Does this make sense? No? Okay, we'll keep practicing. All right, now we can express this as a combined conjunction, and this is where that term comes in. We can express this up here as -1 is greater, let's see, greater than or equal, x is greater than or equal to -1 and less than or greater than, less than or equal to +4. So that's how you would write that. Which I think is easier, because when I see that, then I know on one hand, I have a -1, but it's not greater, it's not equal to. So I've got an open circle at -1, I've got a closed circle at 4, and then every number in between those two, which you can see is the exact same thing as what we have up here. Yes, no, maybe? Okay. Now, the reason we talked about the symbols with sets and subsets is because they have a symbol for conjunction, specifically and. They use this, it's more of like a Rocky Mountain as opposed to the rounded Appalachian Mountains. But this means and. And we'll get into the one that looks like a V means or, but we'll get into that later. All right, so if we give you something like example 2, let's start that back up, didn't I? Yes, okay. Where it says graph and state the solution to x is greater than or equal to 5 and x is less than 0. See what that looks like. So when they graph that, let's see. Get my button. So negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so x is greater than or equal to 5. We would start at 5. And it has a closed circle because it's equal to. And then we have x is less than 0. So open circle, and then it goes left any number less than. We have no common solution to both of these. So because the two graphs have no point in common, there are no points in the solution set. Do you remember the symbol for an empty set? Looks like suspect 0. Yeah. Cool movie. Anyway, yes, the solution is an empty set, which we represent by this crossed out 0. Okay. Because they don't intersect, right? Sure. Okay. Let's see. Those are easy. I think example 3 is easy. That's what we've been doing, where you solve inequalities separately. Yes, what?
All right. What? Wait, what if I missed here? What is going on?
What are you talking about?
What is happening? What is this?
We're graphing inequalities.
That's
So-
not an inequality.
Okay, so you see that 0?
It's 2 inequalities.
It's pretty simple, bro. You just gotta.
It's like you, Gabe.
It's just a 0, and since that's a less than, or is that a less than or greater? It's a less than, yeah.
This is what I mean. He's trying to explain it to me. What is happening?
Let's not.
Well, I
Let's
understand.
move on through. And I think once we practice these, you'll see what we're doing here.
That's me.
Okay. So let's look at example 4 really quick. So example 4 asks us to solve and graph the solution set of -1 is less than 3x plus 5, which is less than 8. So all you have to do when you see one like this is you separate it out and solve for x. So the first one is -1 is less than 3x plus 5. And the second one is 3x plus 5 is less than 8. So we could solve for x. So when you do that, if we look at this one here, Andrew, -1 is less than 3x minus 5. What do we need to do to solve for x? Right. So what's our first step? Reverse order of operation.
I don't know like which
That's okay.
which inequality I work with. I don't know what's happening.
Right now, we're just working with this one.
Okay, so you subtract 5 from both sides.
There you go.
And then you have -6 is less than 3x. And then you divide 3, both sides by 3, you get -3 is less than x. And then you do the other side,
Yes,
okay? So you subtract 5,
from both
Yeah.
sides. Okay.
3x is less than 8. And then, no, 3, sorry.
Okay.
And then you divide both sides by 3 and you have x is less than 1.
Mm-hmm.
And
X is X, right?
yeah,
So you just combine these. Oh, if I could quit hitting that erase button. You can combine these. If you put X in the middle, what would go on the left side of X? X is greater than -2. And X is
less than 1.
less than 1.
It's not 2x. Just normal x.
Exactly. X is X. Because there's only one X in the middle. We've just separated it into 2 different inequalities.
Oh,
And we've created our boundaries. Right, so you just made your beginning and your ends.
That makes
So then when you graph it, you're gonna have your graph have -2 and 1 on it. So I'll go -3, -2, -1, 0, 1, 2, 3.
sense. So you start at -2. Yeah.
If you want, yep, yeah, start on the left, sure. -2,
And it's an open circle.
it's an open circle.
And you go to 1. You go to 1
You go to 1,
with an open circle.
and you have an open circle at 1. So as long as your value for x is between -2, well, less than -2, no, greater than -2, but less than -1, then you will have a true statement. You're just creating boundaries for these inequalities. They don't go off into, some of them will, but in this case, it doesn't go off into infinity. Okay.
I'm angry over here. I don't know what you mean.
Tell you what,
Yeah, I do not remember this, child. At all. I don't even think we did this.
you probably hadn't gotten to it because we're just getting to it.
Oh.
So, I mean, it's inequalities, but it's just from an algebra standpoint. All right. Let me give you guys some more examples. Now, these are going to be, okay. I was like, surely you were not. Okay. Gotcha. Okay, that makes sense. Let's look at some additional problems. We have 5 of them, and then I'll give you guys your homework assignment. We might have time to work through them, at least some of them. Okay, so number 1 is x is less than 8 and x is less than -2. Okay. So Gabe, why don't you do this one? In case your dad gets here before we're done. So how would we graph this?
Start with 0, 0, no. Or no, start with 8. No,
Okay.
start anywhere. But start with 8 in the middle.
We got to have 8 in there somewhere, and we've got to have -2 in there somewhere, right?
Put 8 in the middle.
Let's see. I'm gonna, why don't we do 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We need more room. -1, -2.
The 8, you would get a circle of it. Above the 8.
Okay, open or closed?
Open.
Open circle,
And then go left.
and then it goes left,
And then,
right?
okay, we'll probably open like a 2 first. Oh, wow.
And what?
Okay, anyway, with -2,
Uh-huh,
the open circle
okay.
from other.
So it's going right. So x is greater than -2. Is that what it says? What is this? It's not in your book. This is additional problems.
Oh, I thought that was reversed. Okay, never mind. Make that one go left too.
Right.
I'm sorry, that's the other one.
So x is also, so x must be less than 8, and it must be less than -2. So what are we graphing on our number line? Gabriel? What are we graphing on our number line? Where do these two conjoin? Where is our conjunction? We've written one inequality and we've written the other. What is their set? Where are they the same?
They're not, so you know, right?
Sure.
Huh? Where do they conjoin?
Look at it.
At the -2?
Uh-huh. But does it include -2? Does it? Okay, so what do I put at -2?
I'm confused now.
No.
That's where we got to.
So now we look at where these two conjoin. So -2. What do we put at -2? No, X is the whole set. So we put a open circle because does it include -2? No. And then where does our arrow go? Okay, and it goes to the left. So there's our graph. And so our solution is X is less than -2. So as long, listen to this and then tell me if you're still confused. As long as X is less than -2, it makes both of these statements true. Think of -3. Is -3 less than 8?
Yeah.
Is -3 less than -2? Then that is a true statement.
I don't know what happened to the 8. It's just gone. It's not there anymore.
It's gone because it's not true for X less than -2. What you're trying to do is you're trying to find what values for X make both these statements true. So X has to be less than -8, but it also has to be less than -2, which in this case is easy because it means as long as the number is less than -2, it will also be less than 8. Because -2 is already smaller than 8. Okay, let's do another one. You writing these down as we go along?
Yeah.
Okay, just so you have them for reference. Okay. Number 2. So Andrew, I'll let you have this one. X is less than 4 and X is greater than 1.
The graph has to be a 4 and a 1.
All right, let's see if I put the 4 here. 1, 0, -1. Okay.
And just I can start with 4.
Okay.
And you put a circle. Sorry, above the 4.
Okay, put an open circle above the 4. Okay.
And that's going to the left.
Okay, that goes left. So any number smaller than 4. And then put a circle above 1. Open circle. Okay.
To the right.
Okay. So our set is what?
1 to 4.
All right. And what do I put at the 1?
And open circle.
And what do I put at the 4? Right. So X is, you could do this either way. You could say it's greater than 1, but less than 4.
Yeah.
And that would be a true statement.
Yeah.
That's what I would do. I mean, you could also say that X is less than 4 and greater than 1 and do it like that, but I like it in ascending order. Smallest number on the left. Okay, Abigail, one more. We'll do 3 and then 4, and then we'll work on some homework problems. Okay, so if I have X is greater than or equal to -1 and X is less than -4, what would that look like on a graph? Let's see. Okay. Let me see, let me do 1, 0, -1, -2, -3, -4, -5, -6, -7. We'll go something like that. All right, just start with 1. So let's write x is greater than or equal to -1. So we start at -1 with an opener. You said closed circle? Yes, so closed circle at -1. And then, so it gets smaller. So x is smaller than -1. Is that what that means? What does that inequality say? Yes, we have to ignore the other one. I know it's a lot. So you have to sort of teach, that's why we practice this over and over. You got to sort of teach your brain how to separate the two inequalities from each other, create your different graphs, and then look at where they meet. So x is greater than and equal to -1. And then how do we write x is less than -4? Right. So do they have anything in common? So what symbol do we use to show that they have no values in common? Remember this guy? So it's an empty set. So this means there is no solution for x. There is no number that is both greater than -1 and less than -4. Right? It doesn't exist. They're in two opposite directions. Okay. All right, Eden, number 4. Today, you're getting all the ones that are like jumping to the next level. That's okay, we can do this. 2x minus 3x plus 5. So we're just simplifying once we do that. Is less than or equal to 1. And 4x is greater than 20. So let's simplify. Remember, if you have a negative outside parentheses, you're distributing a -1. So this is 2x, and then -1 times 3x is -3x, and then -1 times 5, -5. All right, and then 2x minus 3x. Right, so negative x minus 5 less than or equal to 1. All right, next step. We got to get all the numbers to the right side with that 1, and you got to have x's and then to write your inequality, right? So what do we need to get rid of? Yeah. So we add 5 to both sides. And then we end up with negative x is less than or equal to 6. But we can't leave it like that, right? So what do we need to divide both sides by? Nope. Gotta get rid of the negative. -1. And when we multiply or divide by a negative, what do we do with our inequality? Yeah, we gotta flip it. So x is greater than or equal to -6. And then this 4x is greater than 20. What do we need to do to get the x by itself? Yeah, so divide by 4, and we get x is greater than 5. Okay, so now we have our definitions for x, so let's graph them. And we've got a negative. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. It's not enough. 12, 13, 14, 15. That should be enough. Okay, so if we did -6, 5, -4, 3, -2, -1, 0. 6. Oh, so let's graph x is greater than or equal to -6. So where do we start? Open or closed? It includes the equal to, so we gotta have it close, because -6 is included. All right, and then which way does our arrow go? If you have these, so your variable is on this side, you follow the arrow of your inequality. So as long as x is greater than -6. It is a Monday. We've had like a whole weekend. Okay, and then x is greater than 5. Right, so open circle. And it goes which way? Yes. So when we graph it, what does our graph look like on the number line? It's only what's included. Where are both of these graphs the same? Where do they cover the same numbers? That's one of them. Where are they both? So you have one that starts at -6 and then starts moving, but then it catches up with the 5 and then they both go. So wherever they meet and both have a positive solution at the same value, that's your starting point. So at this point, your answer is this right here. So what that says is, as long as x is greater than 5, it is a solution for both x is greater than or equal to -6 and x is greater than 5. So this is your answer. Because if x equals 6, +6, is it greater than -6? Sure, it's positive. +6 is larger than -6, and +6 is larger than 5. Does it make you feel better about yourself? Okay. I would call you the antagonist. All right, so let's see. I did not give y'all. I guess I did. All right.
No, we have like 6 minutes.
2 through, I'm looking, I gave y'all 2 through 40.
We have 1 minute.
Well, get out your planners. We're not gonna do all of those. Let's do 2 through 22 even. Page 160, numbers 2 through 22 even. That's a little better than 2 through 40. Especially since 30 through 35 are all word problems. All right. So we'll work on those together tomorrow, but I need them done so I can check y'all's answers. See you tomorrow.